Problem 161 is going to be an example of a kind of an order of magnitude estimate common in astronomy because you're dealing with such large things. If you get the powers of 10 right, you're close. So this says recent findings in astrophysics suggest the observable universe can be modeled as a sphere of radius 13.7 times 10 to the 9th light years, which is equal to 13.0 times 10 to the 25th meters, with an average total mass density of about 1 times 10 to the negative 26 kilograms per meter cubed. But only 4% of this total mass is due to ordinary matter, things we can see traces of, which are protons, neutrons, electrons, anything that when interacting releases a photon, so it's visible. The rest is dark matter. And so it wants us to find to one significant figure the mass of this light matter in the universe. So we have a sphere again. And so the volume of a sphere is 4/3 pi r cubed. It gives us the meters of the observable universe as 13 times 10 to the 25th meters. So we can get the volume as 4/3 pi times 13.0 times 10 to the 25th meters cubed. And so that's going to give us the volume, and we're going to have a unit of meters cubed. But we want kilograms for the universe. So we need to cancel out meters cubed. Well, it's telling us the density is 1 times 10 to the negative 26 kilograms per meters cubed. So those meters cubed here, and the meters that'll cube coming from this here will divide each other out. And so we'll have kilograms. But the one last piece of information is only 4%, and is 0.04. Remember, percentages turn into per 100, so 4% is 4/100ths. Of this is light matter that we can see. So the mass of the universe, our big total mass of the universe, becomes a string of all these things we measured, these unit conversions. And this plugs nicely into the calculator and gives me 3.68 times 10 to the 51st. 3.68 times, times 10 to the 51st kilograms of ordinary matter. But it wanted it to 1 sig fig because we are just estimating. So 4 times 10 to the 51st kilograms. And so that's how much our universe weighs. Now, maybe, the universe is infinite, but because the speed of light limits how much information can be exchanged, even if it's infinite, if you're further away than the speed of light from being visible, you can't interact with anything. And because the universe is 13.7 times 10 to the 9th years old, that's as far as the light can travel in any direction. And so that's why the radius of the universe is limited to the actual age of the universe in light years. That's a neat little thing from astronomy. But our unit conversions get us an idea of how much mass we have in this universe of ours that we can interact with one way or another.